Newton, Maxwell, and the unification of the invisible. How two minds revealed the hidden forces that shaped the universe. By the late 17th century, the work of Copernicus, Kepler, and Galileo had redrawn the map of the heavens. The planets moved in ellipses, Earth spun and traveled through space, and the sky was no longer a realm of perfection, but a landscape governed by natural law. Yet something crucial was missing. These discoveries described what the planets did, but not why they moved at all. The universe still lacked an engine. It needed someone who could look at the motions of the world, falling objects, circling moons, sweeping tides, and see a single pattern binding them together. That person was Isaac Newton. Newton entered history with a temperament that seemed almost carved for discovery. Solitary, intense, suspicious of praise, and relentlessly focused. From his youth, he preferred ideas over people, notebooks over conversation. When the plague forced Cambridge to close in 1665, Newton returned to his family home in Worcester. It was there, in that isolation, that he began the work that would reshape physics forever. Contrary to the popular myth, the apple did not strike Newton's head. It simply fell, and Newton noticed it. Most would have picked it up and eaten it. But Newton, already consumed by questions of planetary motion, wondered why it fell straight down, why the moon did not fall in the same way, and whether a single force might govern both the orchard and the cosmos. In that moment, the ordinary became extraordinary. The falling apple revealed a secret of the universe because Newton's mind had been prepared to hear it. What made this moment remarkable was not the apple, but the mind watching it. Newton had filled himself with the ideas of Galileo's falling bodies, Kepler's harmonies, and the restless motion of the planets. His thoughts were saturated with astronomy. So when he saw a simple apple fall, it was as if all the fragments of the universe aligned in one fragile instant. The question arose not from inspiration, but from mental discipline. Critical thinking had tuned his brain to recognize patterns hidden in plain sight. Once again, the traveler returned to the starting point, only to discover the mystery had been there all along. From these reflections, Newton constructed the most influential idea in the history of science. Gravity is universal. The same force that makes apples fall keeps the moon in orbit, guides planets through space, and shapes the tides. For the first time, Earth and the heavens obeyed the same laws. There was no divide between celestial perfection and earthly imperfection. The cosmos was one system. To describe this unity, Newton needed mathematics capable of expressing continuous motion. No existing method could do this, so he invented a new one calculus. Later, he would claim he developed it for no other reason than to solve a problem, as if inventing an entire branch of mathematics were a minor detail. But that was the scale of Newton's mind. When the tools did not exist, he built them. His work culminated in the Principia, a book so dense, so revolutionary, that it redefined what science meant. Motion, force, inertia, gravity. Newton turned them into laws, precise and universal, that explained everything from the fall of a pebble to the orbit of Saturn. No scientist before or since has changed our understanding of the physical world so completely. Yet Newton was not a perfect rationalist. He spent decades on alchemy, biblical timelines, and mystical speculations. But even these obsessions reveal something. He believed the universe was knowable, patterned, lawful, even if he sometimes looked for those laws in strange places. Newton's curiosity did not stop with motion. With prisms and beams of light, he discovered that white light is not pure, but composed of a spectrum of colors. He redefined optics and designed the first practical reflecting telescope. To Newton, light itself was a key to understanding nature. Every piece of the universe held a secret, and he intended to uncover all of them. But Newton's work, towering as it was, did not complete the story. If Newton united motion and gravity, someone else would later unite electricity, magnetism, and light. The next great step would come from a gentle, quiet genius born a century later. James Clerk Maxwell grew up in Scotland with a personality the opposite of Newton's. Where Newton was sharp and solitary, Maxwell was warm and curious, delighted by patterns in everything from poetry to physics. Yet his mind worked with a similar depth, sensing connections where others saw separate pieces. Maxwell noticed that electricity and magnetism behaved like two halves of the same phenomenon. With extraordinary insight, he unified them into a single structure, the electromagnetic field. Then, with a set of equations elegant enough to resemble music, he revealed that light itself is an electromagnetic wave. In one stroke, Maxwell showed that magnetism, electricity, and light were not separate forces, but expressions of one underlying harmony. His equations predicted the existence of invisible waves, radio waves, decades before anyone discovered them. What Newton had done for motion and gravity, Maxwell did for light and fields. The universe had once again grown simpler, deeper, and more beautiful. Newton explained how planets move, why apples fall, and how motion works on Earth and in the heavens. Maxwell explained what light is and revealed the invisible forces weaving the cosmos together. Their discoveries did not merely solve problems. They uncovered unity in places no one had thought to look. The cosmos, once fragmented into separate mysteries, became a single tapestry governed by a few grand laws. Yet their greatest gift was not their theories, but the pattern they illustrated. When the mind is fed with truth, disciplined in thought, and trained to question, it begins to see meaning everywhere, even in falling apples, flickering magnets, or beams of sunlight. The universe does not bend to our assumptions. It does not flatter our hopes or fears. It simply is. And through Newton and Maxwell, humanity learned to see it more clearly.